Welcome back to solving numerical problems in engineering mechanics, written by Professor Timoshenko and D.H. Young from Stanford University. This is a really interesting problem. You can well imagine such kind of problems to be expected in your IIT Advanced Entrance Examination if you are an aspirant for it in 2021 and thereafter. The problem is from friction. I'll be explaining the angle of friction and how if there are 5 different variables and there are 4 different equations, it will be not possible to simplify it in a if there are 5 different variables and you have 4 equations, it will be difficult to find out the variables. So I'll make a different approach to solve it. So problem set 2.7, solution to 2.117 from engineering mechanics. Let us begin by, let me read out the statement first. 2 blocks having weights W1 and W2. Here is a weight W1, here is a weight W2. Both are resting on horizontal surface. This is a horizontal surface. But the surface is not smooth, means rough surface, so there is force of friction is present there. 2 blocks having weights W1 and W2 are connected by a string and rest on a horizontal plane as shown in this figure F, given in your book. If the angle of friction for each block is phi, the angle of friction for this block is phi and also for this block is phi. And as we know, tangent of the angle of friction is nothing but the coefficient of friction. And the meaning of coefficient of friction is more the value of mu, more is the friction. If the angle of friction for each block is phi, find the magnitude and direction of the least force, the minimum force P applied to the upper block. This is the upper block, this is the lower block. This is kept at a lower platform, this is kept at a higher platform, so this is lower, this is upper. We have to find out the minimum value of P that is applied to the upper block, so that will induce sliding. So here is a force P applied. This angle is not given. I will take it as alpha, and both the blocks are connected by a string. So there will be a force of tension also. So let S is equal to the tensile force in the string. This string S. You can represent it by T, no problem. Now it is also given tan phi is mu for both the blocks. Means coefficient of friction here and coefficient of friction here are same. And now that is what do you mean by this? That is the tangent of the angle of friction is equal to coefficient of friction. This is the English translation of this mathematical expression, which you derived in your school days. I will derive it once more here and then solve it. Now, since the angle of friction here and here is phi and both are same, so tan phi, which is nothing but the coefficient of friction between this block and this surface, this block and this surface, is same as mu. Therefore, mu for both the blocks are same. Now, what else? Neither P nor S are horizontal. If you look at P is making some angle with horizontal, the tension force developed here, which will be away from for the W1 to this side and away from W2 to this side, both are also not vertical or horizontal. So both P and S will have both horizontal and vertical components. So both P and S can be resolved into vertical and horizontal components. Now, let me explain you the angle of friction, then we'll go back to solving the problem. If you look at the diagram here, this is a block having weight W acting vertically downward if its mass is m, g is the acceleration due to gravity, so the weight is acting vertically downward from the center of mass. Now, if you are trying to pull it to the right hand side, to this side with a force F, means this block is tending to move to this side. So the force of friction for this block will be towards the left, let it be F. And this is your action force weight, that is mg, that the block is applying on the horizontal surface vertically downward. So the reaction force will be exactly opposite to that according to Newton's third law of motion. I call it normal because this is a surface and this reaction force making angle 90 degree with the surface. So I call it normal. So there are two forces, the force of friction, the normal reaction. And since F and N are perpendicular to each other, if you apply parallelogram law of vector addition by constructing a parallelogram, then this length from here to here will be the resultant of this normal reaction and F. And the angle this resultant makes with the normal reaction, that is this angle, is called the angle of friction by definition that you must have studied in your school days. So if you take tan phi, tan of this angle will be perpendicular over base, and this perpendicular is same thing as F, and the base is your normal reaction. So your tan phi will be perpendicular over base, that is F over N. And in the laws of, from the laws of friction, F over N was your coefficient of friction. Now then come back to the original diagram. This W1 is being pulled to this side with a force P. So let me take this angle as alpha, which I have shown it here. And the string which is connecting both the blocks W1 and W2, there will be a tension force which I have represented as S. So for this block S is to this side, and for this block S is to this side. The same S, the tension force S. Why S is to this side for this block, why S is to this side for this block, is simply for the fact that if you take a string like this and try to push somebody, you cannot push him with a string because it is not a rigid body, but you can pull him. So therefore the tension force S for this block is away from it, and the tension force developed in the same string for this block is away from it, the same S, both are same. And if I draw a horizontal line, let this angle is beta, this is also horizontal, so this angle will also be beta, because this dotted line and this dotted line, they are parallel, this is the transversal, so if this angle is beta, this will also be beta. So when you are pulling this weight W1 to this side with a force P, making an angle alpha with the horizontal, what will happen is this part, from here to here will be P times cos alpha, due to which this block W1 will tend to move to this side. So to oppose its motion, the force of friction, let it be F1, between the block lower surface of the block W1 and this surface, the force of friction will be to this side. So when W1 is applied with a force making an angle alpha, the force is P, and this one is your P cos alpha. Let me write it here, P cos alpha. This string will come under a tension, and what will happen, this component which will be S times cos beta will try to pull this weight W1 to the left, towards your left. So here the force of friction, let it be F2, will be towards your right. So both F1 and F2 are towards right. Now the weight of this block is W1 acting downward. So let R1 be the normal reaction. Similarly here the weight W2 is to this side, so the reaction is R2. I have represented as R2 and R1 and R2 with two different symbols because the weights are different, so the reactions force will be different. So the reaction force will be different. Now there is something interesting now that comes into play here. There are 5 unknown quantities. Alpha here, beta here, the two different angles. The force of tension developed in the string S, the normal reaction R1 and R2. So all these 5 quantities are not known. Then you might ask, why should not I say this F1 and F2 are not known? Because force of friction is mu times the normal reaction. Force of friction is mu times the normal reaction, which I have represented as R1 and R2. So since W is known, W1 is known, therefore R is known, R1 is known. Since W2 is known as W2, therefore R2 is known. And since mu is known, because tan phi is mu, therefore the force of friction is known. So the force of friction is not an unknown quantity. So these 5 quantities are the unknown quantities. Now, as you have seen before in previous videos, if you apply sigma x is equal to 0, means sum of the forces along x-axis 0 for this block, it will give us one equation here and one equation here. Applying sigma x is equal to 0 here, sigma x is equal to 0 here, means sum of the forces along x-axis is 0. You will have an equation here and you will have an equation here. So there will be 2 equations. So sigma x is equal to 0, it will give us 2 equations, one here and one here. One for W1 and one for W2. Similarly, if you apply sigma y is equal to 0, that is the sum of the forces along y-axis is 0 for equilibrium. If you apply it here, you will have one equation. If you apply it here, sigma y is equal to 0, you will have another equation here. So by applying sigma x is equal to 0, there are 2 equations, one here, one here. By applying sigma y is equal to 0, there is one equation here, there is one equation here. So in all, there are 4 equations. So that is what I have written here. Similarly, if you apply sigma y is equal to 0, it will give us 2 equations, one for W1 and one for W2. So we have 4 equations but 5 unknowns. And the basic principle of mathematics is, if you have 5 unknowns, you need 5 linear equations, independent linear equations to solve for their values. Means if you know 5 different equations, linear equations, independent of each other, then you can find alpha, beta, S, R1 and R2. And since here the number of unknown quantities are 5, and the number of equations that we can develop by applying sigma x is equal to 0 and sigma y is equal to 0 is 4. So that becomes a tedious process. So then I have to apply a different technique. I can combine the forces. So let me draw a free body diagram for W1 and then for W2. For W1, a free body diagram for W1 and a free body diagram for W2. That is what I have shown here. So this is what I just explained, 5 unknowns, 4 equations. So let us draw the combined force diagram, which I will draw later on. Let us draw the free body diagram for both the weights, W1 and W2. If you look at W1, this is your W1, that is same thing as this. This is your W2, that is same thing as this. To W1 you have applied a force P, making angle alpha with the horizontal. That is what I have shown here. The normal reaction R1 with W1, and as this W1 is pulled to this side due to P cos alpha, the force of friction F1 is to this side. That I have shown here. And force of friction is mu times normal reaction. And this string making angle beta with the horizontal. So the component of S, so this S makes angle beta with the horizontal, that also I have shown here. Similarly for weight W2, the weight W2 is pulled to this side due to S cos beta, a component of the tension force S. So the force of friction F2 is towards the right. So that is what I have shown here. F2 is equal to mu times R2. And the same S, making angle beta with the horizontal, that I have shown here. Reaction R2, weight W2. Reaction R2, weight and W2. So this is the free body diagram for W1. This is the free body diagram for W2. Sorry, the camera got checked. I hope it is still clear. Then coming back to the important point here, another important point here, another important point here. Mu is same for both the blocks. Why? Because it is given for both the blocks, the angle of friction is same, means tan phi is same, that is mu. Therefore, mu is same for both the blocks, W1 and W2. So, mu is same for both the blocks since it is given that tan phi is mu. Is same for both. This is same for both, it is given. Therefore, mu is same for both the blocks W1 and W2. So, now then R1, R2 are of different magnitudes since both the blocks are having different weights. W1 is different than W2, so I have represented one as W1 and the other as W2, means W1 and W2 are different. So the reaction force will also be different. Therefore, R1 and R2 are different magnitudes. The directions are same, vertically upward. Then the third conclusion is force of friction, that is capital F1 and capital F2, which I have represented here and here, will be different because although mu is same, the reactions force are different, so the force of friction F1 and F2 will be different. So in such a situation, so what I have to do is I have to draw the combined force diagram. Now look at this. This is the combined force diagram. How this is the combined force diagram? R1, R2 are in the same direction, so I have taken them along positive y-axis. Then the force of friction F1 and F2 are in the same direction, and I have taken them as along positive x-axis F1, F2. And this is your P, making angle alpha. That I have shown it here, P making angle alpha. And the weight of this one, W1, and the weight of this one, W2, both are pointing in the same direction, that is along negative y-axis. So I have shown them. So I have shown them here. From here to here is W1, from here to here W2. We don't know whether W1 is greater than W2, doesn't matter. Whether R1 is, we don't know. So it doesn't matter whether you consider this as W1 and this as W2, doesn't matter. If you consider from here to here is W2 and from here to here is W1, then from here to here will be W2, then from here to here will be W1. But that does not really matter. It will give you the same answer, right? So once we have drawn the combined force diagram for both the blocks, for the fact that we have 5 different variables and 4 different equations, so I have done it that way. I have combined the force diagram for the block 1 and for the block 2. Now then it becomes very simple, hardly 2-3 minutes to finish. Let us apply sigma y is equal to 0, that is sum of the forces along y-axis 0. R1, R2 are in the same direction, and a component of P, that is this component, If you drop a perpendicular, this is the component of P along negative x-axis. If you drop a perpendicular here, from here to here will be the component of P along positive y-axis. This component will be P times sine alpha. How do you get that? In this triangle, if you take sine alpha and cross multiply, you get this length as P sine alpha. So P sin alpha, R1, R2 are in the positive y direction. So I have added them. And W and W2 are in the negative y direction. So I have added them. So for equilibrium, they have to be equal and opposite. So now what do? You take this term to the right hand side. So it is subtracted. So from, let it be equation 1. Then apply sigma x is equal to 0. F1 and F2 are in the positive x-axis, and the component of P along the negative x-axis, that is this length will be P times cos alpha. So P cos alpha will be balanced by F1 and F2. So P cos alpha is equal to F1 plus F2, where capital F1 is the force of friction for the first block having weight W1, capital F2 is the force of friction for the second block which is kept at a lower level. And since force of friction is mu times normal reaction, so this will be mu times normal reaction, this will be mu times normal reaction, mu is same, which I just explained, because tan phi is given as same for both of them. So by taking mu common, you get R1 plus R2. Now what you have to do is put this value of R1, R2 from equation 1 here. So P cos alpha remains as P cos alpha, so mu times, for R1 plus R2, I substitute this value. Now then everything is left for algebra. So mu will be multiplied here, mu will be multiplied here, mu will be multiplied here. After multiplying mu with this term, I take it to the left hand side. So this becomes P cos alpha. This comes to this side, plus mu times P sin alpha. We are left with W1 plus W2 times mu. Now then your last part. In this video you will find the sound little better audible, because I have purchased a new sound system so that the sound becomes better audible. So now what do I do is take P common from here. I have taken P common here. I have left with cos alpha plus mu times sin alpha. Mu times W1 plus W2 remains as such. Now let us apply. Since I explained how tan phi is equal to mu, so mu is equal to tan phi is same sin phi over cos phi. Now put this value of mu, that is sin phi over cos phi here. Now then cross multiply. So P remains as P cos alpha mu. For mu I write sin phi over cos phi sin alpha. For mu I write sin phi over cos phi W1 plus W2. And if you take LCM here, we are having LCM cos phi. So cos phi is multiplied here. Cos phi times cos alpha plus sin phi times sin alpha. So sin phi times W1 plus W2 over cos alpha. Cos phi cancels. Now this is a simple trigonometric formula. Cos A cos B plus sin A sin B, that is equal to cos of A minus B, that is cos of phi minus alpha, is equal to W1 W plus W2 times sin phi. So we are supposed to find out the minimum value of P. So I keep P on the left hand side, take this term to the right hand side, so it is divided. So this is a fraction. Now is interesting. And as you know, in a fraction, this fraction is the value of P. So if the denominator is maximum, if this is maximum, then this divided by this will be minimum, and this divided by this is P. If the denominator becomes maximum, so look at, suppose 6 by 4 and 6 by 5. Whether this value is more or this value is more, the numerator is same. In this case, the denominator is more, so this value will be less and this value will be more. So that is the simple concepts from algebra. So P will be minimum if cos phi minus alpha is maximum. and in cos table the maximum value of cos is 1 and that occurs at cos 0 degree. So cos phi minus alpha is cos 0, so phi minus alpha is 0. That is what I've written here. So phi is equal to alpha. So when this is maximum, that is 1, your P is equal to minimum. So your P minimum will be this divided by 1. Now, divided by 1. And I have just proved phi is equal to alpha. So here for phi, put alpha. So this becomes W1 plus W2 sin alpha. So this is the minimum value of P. This is the minimum value of P, which I have written it here, for which the minimum value of the force that you have to apply to this block, making an angle alpha with the horizontal, so that the force P will induce a sliding on this block and this block. I hope it is clear to you. The video has become lengthy, but still it is okay, and you are comfortable with the description and the way I explained it to you. Please don't mind to subscribe the channel and pass on to your friends who find engineering mechanics difficult. My intention is to help you out, the people studying in different engineering colleges and preparing for GATE examination also. So thank you very, very much. From this video onwards, you will find the sound more audible, more stereophonic, because I have purchased a capacitive sound system. Thank you very much. And if you have already subscribed, I thank you very much. If you have not, please go ahead and subscribe and pass on to your friends. And thank you. All the best. Thank you.